Hello, my name is Duckademy. Welcome to this Docker course. In this course, you will learn all aspects of Docker from beginner to advanced level and how to use it in your infrastructure or on public cloud providers. The course will cover the basics and fundamentals of Docker and Docker infrastructure, how to manage your Docker containers and images. You will learn the advanced usage of Docker and the Docker containers and your Docker infrastructure. You will learn how to run your containers in an enterprise environment with external storage providers and with advanced networking infrastructure. And also you will learn how to run your Docker containers on public cloud providers, just like Amazon or Google Cloud Engine. In this video, we will cover the difference between the traditional virtualization and containers, what's the difference between the full or OS containers and between application containers. You will learn the basics of a Docker image and how a Docker image looks like. And you will learn the basics of a Docker infrastructure and what parts it has. So, how a traditional virtualization works and what is it? In a traditional virtualization, you use your general infrastructure, your servers, storages, switches, and so on, and you put an operating system onto your real servers, just like Windows or a Linux. And after that, you put a so-called hypervisor on top of the operating system. So in the case of Linux, you will install the KVM, and in a case of a Windows or Windows core server, you will install the Hyper-V feature onto that. So Hyper-V and KVM are hypervisors, but there are several specialized operating systems which consist the host operating system and the hypervisor in one, just like the VMware ESX or the Xen server, which provides you with a minimal operating system and the hypervisor itself in one installable package. Okay, and after you just install your host operating system and the hypervisor, you can create virtual machines. And the hypervisor will emulate the hardware to these virtual machines. It will emulate the motherboard, the CPU, the memory disk, network interface card. And you will install the guest operating systems into these virtual machines. And the guest operating system install is a simple install. There are no special requirements, because the hardware is emulated, but it comes with a price, the performance penalty, because everything is emulated. So when you write data onto the disk in the virtual machine, first you have to write it out in the virtual machine disk, but the virtual machine disk is a real file on a host operating system, so you will write out that data onto the real disk into a real file. So there's at least a double write occurs. And the same happens with the network interface card and so on. We have specialized drivers called paravirtualized drivers, and when you install it into a guest operating system, it boosts the performance because it will evade the performance penalty with directly talking to the disk or the file on the host operating system. So it helps you a lot. But still, it's just like a real server, so you will have to administer the servers, the virtual machines, just like normal server, so you have to patch all the application, all the operating systems. The traditional virtualization has the advantage that you can install different operating systems on top of another operating system. So let's say you have an Ubuntu host operating system with KVM hypervisor, and you can install a Windows server or a Linux server or a FreeBSD server on top of that. It doesn't matter, because on a virtual machine there will be a separate kernel for all the virtual machines. This is just like a normal server install. So why we use traditional virtualization? In the first place, traditional virtualization is used to consolidate the hardware and the infrastructure. So you have a better usage of your infrastructure, because you can put more operating systems, more machines on real servers. Because in real life, 80% or 90% of all the time, the operating system is just idle, or it just uses 10 or 20 or 30% of the hardware resources. So if you put more machines, more servers into one real server, you have a better average consumption. So you will spend less money, because you can put more servers on one physical machine, and one physical machine consumes less electricity than 3 different servers. So this is the main reason behind the traditional virtualization, the better usage of the infrastructure. And on the second thought, you can just think about different software versions and different libraries which are not compatible with each other. So let's say you have 4 applications and you want to put them onto one server, but they are requiring the same software but with different versions which are not compatible with each other. So let's say you have to use MySQL 6 or you have to use MySQL 5 or PHP 7 or PHP 5.6, and they are not compatible with each other. But your application, maybe they just require different versions. And you can just manage it, but it's very hard because you can install them into different directories, work with different environment variables. But it will be very hard to maintain, patch, and update all these things, okay? So on the other hand, you use traditional virtualization to isolate the processes and to give the different applications different virtual machines. So that's much easier to manage different virtual machines with applications than one real server with 5 different applications. And anyway, we have lots of tools to orchestrate and schedule these virtual machines. You can just install them with the help of Chef or Puppet or anything just like that. So you can automate all this process. But still, you have a performance overhead and a management overhead as well, because you have to patch all the operating systems by itself, and it consumes more hard disk, more storage, and so on. So we have another virtualization called containers, and the first occurrence of the containers happened just like the full containers or operating system containers. And they are almost the same as the traditional virtualization because you use them to isolate and separate the different roles, different customers, or different applications. And you install whole operating systems into the containers. You have a full boot sequence, there's an SSHD or a remote desktop if it's a Windows. You have a MySQL server and an Apache Web Server in one container, and you just put another version of Apache Web Server and PHP and MySQL into another container, and there will be a full boot sequence. And you can use the same upgrade methods just like with the traditional virtualization. You can use almost the same orchestration tools. You can use Chef, Puppet, Ansible to deploy these containers, these operating system containers, onto the host operating system. But there's a very big difference between traditional virtualization and a container virtualization. And this difference is that you cannot use different operating systems on top of each other. So you cannot use a Linux on top of a Windows server, and you cannot install a Windows server on top of an Ubuntu host operating system. With a container virtualization, you have the real servers and the host operating system, and you have a container management service, just like OpenVZ, vServer, LXC, and so on. There are lots of different flavors of this container management service, but one thing is common in all of them, that they isolate the different processes. So when you install a guest operating system, you just install it into a directory of the host operating system. And when you boot the container, it just starts the processes, and the processes are isolated from each other. So if I have this green guest OS and this orange guest OS, they are just processes, and there is no hardware emulation. So in traditional virtualization, because the hardware, the motherboard and CPU and everything is emulated, you can install different kernels into these virtual machines. But with containers, you use the same kernel on the host operating system. So the kernel is one. You cannot use different kernels in a guest OSs other than the host operating system, because a container is just a process. And the processes in the container are just processes on the host operating system. They are just separated from each other and separated from the host operating system processes as well. And you can put limits on them. So you can limit the memory and the CPU usage of a container. but you can only run a Linux container on top of a Linux operating system, and you can run only Windows containers on a Windows server. But it has a very big advantage that's very fast. It's nearly as fast as a real server because there's no emulation, so it's much faster than a traditional virtualization. And if you run Linux on Linux, it doesn't mean that if your host operating system is an Ubuntu, it doesn't mean that you cannot run a CentOS or Red Hat Linux version as a guest operating system. Only the kernel will be the same, but all the libraries, the server versions, and so on will be the guest operating system's versions. So you can run a CentOS, SUSE, or a different version of Ubuntu on a Ubuntu host operating system. But still, it looks like a real server with all the boot sequence and all the softwares. So we will have the SSH daemon and so on, as I just told you before, to manage, to log in to that guest OS and to manage them, okay? And the very big difference between an application container and an operating system container and an application container and the traditional virtualization is that you won't ship full operating systems in an application container. We have several application container engines, but Docker is the most famous and this is the most mature. And what an application container is. So you still use your servers and you put an operating system on top of that. So let's say as an operating system you will install Ubuntu, but you will install the Docker engine on top of that. And you will not ship and deploy full guest operating systems with full boot sequence, SSH daemon, or mail server daemon, or an Apache web server in one package or in one directory. You just put your application and all the required libraries and software in one package. So if you have a WordPress install in an operating system container, you would install an SSH daemon, an Apache web server, the WordPress files, a PHP library, the MySQL, and the mail server on top of that guest OS. With an application container, you use different containers. And let's say, again, that WordPress example works like the following, that you will put your WordPress and your custom theme into the green application container, and you will put the MySQL server into another container. Let's say the MySQL is the orange one, okay? And then you link them together. So you will only pack your WordPress and WordPress theme into one container with all the required binaries and libs, just like the Apache web server and the PHP files, and you will use a standard MySQL image in another container. So why is it good for you? Because if you are a developer, you can just pack your application into one standardized format and you can just deploy your application anywhere where Docker is supported. So let's say you have your custom software packaged into the red application container, and it doesn't really matter whether you deploy it onto Amazon or Microsoft Azure, Google Cloud Engine, or your own laptop. It will work the same way because all the required dependencies, binaries, libraries are in one package. You can just compare an application container to a portable executable that if the runtime environment supports your application, you can run it, just like portable executable versions of Mozilla Firefox with an executable format, Windows executable format. You can run it on any Windows versions. This is the same. If you have a Docker container and this Docker container consists of Linux binaries and Linux applications, you can run it on any server which supports the Docker engine and the operating system is Linux. And it works in the same way with a Windows server as well. So from a developer point of view, it's just very easy to pack your applications into one package and run it anywhere. And from the infrastructure guy's point of view, if you are an infrastructure engineer, you don't have to work with dependency house and you don't have to provide several scripts just to maintain status quo in the servers. and to be able to run only one application, because you will get rid of this dependency hell, because you only have to provide the Docker engine and the basic infrastructure, and developers will take care of anything else. Okay? And as an application container, just like a Docker container, is very lightweight, you can run more applications on one operating system, on one server, than with operating system containers or with a traditional virtualization. With traditional virtualization, okay, it just depends on your hardware, but sometimes you can just run 10, 20 virtual machines on one server. But with a Docker application container, you can run just like 100 containers. Okay, it just depends on how much memory it uses and how much memory do you have, but you have the possibility. And this application container format, it's very good to run the so-called microservices. So if you have one web application and you need to deploy just like 50 more from that web application, you just deploy 50 containers, and you don't have to wait for an operating system install or use it from template, because you just deploy your web application and the Docker engine will take care of all the other things. And the other big advantage beside the standard format and the low resource usage is that it's much easier to deploy new versions, because let's say app 1 and app 2 are just two different versions, but from the same software. When you want to deploy a newer version from your software, you just deploy the app 2 container and just stop the app 1. And if anything goes wrong, it's very easy to downgrade or roll back the software installation, because you just start up the app 1 container and just shut down the app 2 container. And when you deploy, you don't have to wait for the infrastructure guys, and as an infrastructure guy, you won't have extra work just to make sure that the newer version of software can be rolled out. So these are the biggest advantages of a Docker environment. Okay, the Docker environment works with Docker images. So the containers are the running versions of an image. And an image is just like an executable, and it has several layers. An image has several layers. How is that? When you start a container, you will start up an image and make it run. And let's say in that example, you have that Apache container and you have that Apache image. But Apache needs an operating system as well to run, or the libraries. So it doesn't require a full operating system, because the host operating system provides all the memory management and so on. So you only have to have the binaries required to run the Apache. So you put your Apache into one image, and maybe it has dependencies. So it has references to another parent image. In that example from docker.com, it's the image. So it will just reference to that other image, and it just grabs that image as well. And that image references to the Debian base image. And the Debian base image is not referencing to anybody, because it's a base image. So when you want to run the Apache container, you grab the Apache image, and that image will point you to other images. And at the end, the Docker will put all the layers on top of each other. Okay, so it will just grab the base image, put the image on top of that, and put the Apache image on top of that. And at the end, it will create a read-writable layer on top of that. So any change which has been made, so any change will be written into that read-writable layer, because the images are immutable. That means I can use the same image for several containers. So if I want to run 100 Apache containers, I will use the same image, and they will be only different with the read-writable layer, because every image will have a different read-writable layer. But this layer is ephemeral. So what does it mean? It means when I remove the container, that writable layer will be lost. So if I just delete all the Apache binaries, I just remove the container and start up a new container from the same image, and because the image is immutable, so all the changes are lost because they live only in the active container. Nothing is lost. Okay, so everything is just happening in that read-writable layer. but not in the base image. And because I can use the same image for several containers, it consumes less storage space. Because in a full container or in a traditional virtualization, if you have an image with 1 gigabyte in size and you start or deploy 100 containers, it would consume 100 gigabytes. But in a Docker infrastructure, if you have an image with 1 gigabyte in size and you deploy 100 containers, you still use the same image because only the read-writable layer is different. So it will only consume 1 gigabyte disk space and the read-writable layer's disk space consumption. Right now, all you have to know is that Docker containers are coming from images, and these images are immutable. And the containers are ephemeral, or the read-writable layer of the containers are ephemeral. So if you remove a container, everything will be lost, which has been written into this read-writable layer. You will see in later videos that there are persistent data stores, what you can use with containers. So if you have a real application, you won't lose your data if you just remove a container. So don't be scared when I say the read-writable layer is ephemeral and the images are immutable, because you can store your changes. Okay, at the end, let's see how a Docker infrastructure looks like. This is a very simple Docker infrastructure. Because you have your Docker host, let's say that's in Ubuntu or CentOS, Linux, and you have the Docker daemon on top of that Docker host. And when you want to start up a container, right now you know the Docker uses images to create containers. So the Docker daemon will look for the images locally. And if it doesn't find the images, it will pull them from a so-called registry. So you store your images on a registry, and these images will be downloaded when necessary and will be stored on a Docker host to create containers from that images. Okay, so the Docker client just issues command to the Docker daemon, and the Docker daemon will behave just instructed. Okay, so this is the basics of the infrastructure. You start up a new container, the Docker will just take a look whether it has image for that container, and if it doesn't have an image for that container, it will just pull it from a registry. It can be a public registry or a private registry on your site. It just depends on the configuration. Okay, and it will just start up a container. Later you can remove the locally stored images, you can upgrade the images from the registry, and so on. So these are the basics of a Docker infrastructure. And in the next video you will see how to install Docker on an Ubuntu host.